So, welcome back. In today's video, in today's session, I will be writing a HTTP web server uh, from scratch, and I will start with an empty page, and by the end of the session, we should be able to serve HTML files or JavaScript files, CSS files, maybe images by the end of the session. So let us start. Let us first look for HTTP 1.1 spec, the specification. Just taking time. So on the surface, the web server looks a bit different, something different, but at the end, it is a socket-based application where we create a socket at the server side, and browser creates a socket at the browser side, and we follow a protocol. We communicate based on some protocol, that is HTTP 1.1. This is the HTTP 1.1, and let us see what it is. Let us just start with the very basic communication. So basically, we are implementing this specification, this spec. This is the entire specification. Let me search. Right now we are only interested in, let me give some example. For example, when a request comes from a browser to our web server, it sends a stream of bytes, and it has different meaning, and of different parts have different meaning, and those parts and what location those are going to occur are fixed. For example, when we make a request, the first thing we is sent to us is the method type. Let me see some examples. This is my website where I'm working on developing some utility tools for my website. It is taking some time. It is taking a lot of time. So this is how a request goes to the server, that not to get any response, that we are sending some method uh, type of call that we are sending to the server. I don't know why it is not working, but okay, we've got the result. It took some time. So what we do, we are sending, if you look at here, that we're sending the method type, that it is get. Then we also send, this is not from, this is from server, response from the server. This is the response from headers, but we send the method type. We also send the path that we are trying to fetch. You can see, you can look over here that we are sending a method type, we are sending the path, we provide the scheme type, that is the protocol type, and so on. We provide the cache control, pragma, and others. So what we right now need for our basic implementation is that we only need the path. because we are only going to implement the get part. So we will just skip this method, skip this part, and only care about the this path. And depending on the path, we return. If we read data from a file and return it to the server. So I should there should be some example response request to make it more clear. Yeah. This you can see that this is the way requests comes to the web browser. So we will only care about the first line because we are not parsing the rest of the information. The first that comes to us is the method type. Then comes the path, that is pub www. That is the path. It can be a file name, for example, index.html. Then this is the protocol that we are going to implement. So let us start. Let me open the API docs for Java 23. Let us put this to some use. Write socket connection. Then we are going to extract path name, and then we are going to read a file from disk, that is our computer. What is this? Write the information back to the browser. Clean up the socket connection. So these are the 5 things that we are going to do. Let us start. Right, socket connection. Go back here. We'll look for API docs. Okay, here. And I will go to server socket channel. Server socket channel. So from here, I will be first creating a socket connection, server socket which accepts some connection at particular port with the local address. Okay, so my dev utils, this is the browser, API docs. Okay, here. This is my http server.java, and I will be writing code here. Let us start. Let me increase the font size, I think. Okay. Import, and I will start with java.nio. This is our import over here, java.nio.channels. Here, java.nio.channel, server socket channel. Let us start. Let us import everything from here. This is the first import that we need. Let us write the code for the class. Public class http server. The class name has to match the file name. I'll write entire code in a main function without any helper function, so we don't have to jump back and forth for seeing what the code is doing. And which is going to be public static void main. uh, this is the first test to see that our code is running, our file is running. So we'll go to the command line and say http server.java. So compilation is successful. So first we need to do is create a server socket. So I will say server socket, not here but in a try with resources fashion, so that it can be closed on its own. So we have server socket channel, and we are going to use a factory static factory method for that. Server socket channel dot open channel is equal to server socket channel dot open. Then we need this server socket to bind to some address. Just check that bind socket address local socket address. Let us see what the socket address is. Socket address is java.net socket address. So we'll have to import java.net.star socket address, and we can create socket address over here. Socket address local address is equal to, where is the class? This is an abstract class, so we need a concrete implementation, which is the inet socket address. I will go to this class. It is in the same package, so we don't need to add it to import. This class implements an IP socket address, IP address plus port number, so we can create that, and it takes a inet socket address takes a inet address. So let us see what the inet address is. It is also in the java.net package. I will use the localhost starting method. So start with, here I will say new inet socket address, and inet address dot get localhost. Get localhost, this is the local address, and we also need to provide the port. So I will say, generally we do 8080, but I will say something like 5432. This is where our browser is going to listen. Our server is listening to this port, and let us print this system.out.print ln listening at local address here, and I can say server socket.bind local address. Okay, so it is there. So we have created an local address. Instead of running server, I can say starting server listening at local address at this, and we open a server socket channel. We bind it to the given local address, and we can proceed further with that, but let's see, first check that it is compiling. Try with resources must either be a variable declaration or an expression denoting a reference to final, effectively final variable. This won't work. Final or effectively final, so we can say, but it is final. Okay, then we are going to move it here. Let us run again. Unreported exception, unknown host exception must be caught or declared to be thrown. Okay, I'm going to say throws an unknown host exception and IO exception. I don't want to litter my code with catching exceptions. Let us see it is compiles or not. Cannot find IO exception, so let us go back here and say import java.io.star. I think this IO exception lives in this package. So we have successfully our code is compiling till now. Starting server and listening to this is my laptop name. This is the IP address, the local IP address. This is the port number. So when we call from the server, it is going to be this address. So this is going to be like this. It won't currently work because we haven't started our code, but this is the URL we are going to trying to access to check our code that our server is working or not. So this is server is started, then server is closed because this is try with resources. And what are we going to do next? I will say while true, because we want our server to keep working and keep serving requests. So we are going to say while true final socket channel. I will say request socket is equal to server socket dot, I think it's something like accept to accept a request coming from our client socket channel. This will accept a request from the server, and once that is done, I will go to socket channel and see what functions it has to read coming data from our client. It has bind. It is in the case of when we are just creating a client socket, not server socket. Finish connect is connected. Open read byte buffer destination. So we are going to use this. We are going to use this. What is called this function to read input coming from the server, the browser. Sorry, coming from the browser to our server. So we need a byte buffer which can keep data for us. So I will say final byte buffer read store, something like that. We can say request data buffer, say byte buffer dot allocate 1024 bytes, that is 1 kilo, that is it is 1 byte. Yeah, okay, this is 1 kilobyte of size of data. Go back here, we'll go to the byte buffer to see what we need to import. We need not import anything because it already is in the Java NIO. Okay, we need to import, for example, I will have to say Java NIO dot byte buffer for this byte buffer class. And byte buffer has a static method. I think it has a static method to allocate byte buffer, that is allocate with int capacity. Okay, so we have incoming, we accepted the incoming request at line. We have accepted the incoming request here. That we accept the incoming request, we create a request channel, and I will say request channel, and I will use a request channel dot read, and I will say request data buffer that read all the data coming from the request from the server, sorry, from the browser in this buffer. And I will, after we read the data from the buffer, I will say request data buffer dot flip before you want to read it. This is what is called, we are reading the request, we are opening accepting the connection at line 12. At this line request channel dot read, we are reading all the incoming request data, that is the method type, the path, and the request protocol and cache and content type, anything that coming from this browser here. Then we flip this buffer, so prepare for reading, we'll be reading over here, and I will say let us print it to see what is what are we getting from the server, from the browser. Let's say arrays dot to string request data buffer. This, and let us put this this accepting incoming socket at in the try with resources also, that so that after the request is over, this is closed. Request data buffer dot flip, we'll be reading the data and see what is coming from there, or you can just try to extract the information from the request data buffer. Or we can see what is happening. I can say, for example, find the string log data is equal to new string request data buffer dot array. This is the byte array, starts with 0, and request data buffer dot limit, and I will print this log data to check that what is coming from there. So what is happening till now, we created a server socket and we bound it to the local address that is printed in the, that first we saw printed in the command line, and we accept the request incoming from the browser. We read all the incoming data from the browser in our data buffer, and we requested buffer dot flip, we start, because we basically reset, we move the pointer, the current position to 0, so that we can start reading the data, and we are converting the current information in our buffer to a string, so that we can see what is the information coming to us. So request data buffer dot array, this is the byte array that buffer has, where it stores the data. This is the offset, the position where we start reading the information, request data buffer dot limit is what is called, it is the last index where our last valid data is. So that, for example, the capacity of this buffer is 1 kilobyte, 1024 byte, 1 kilobyte, but we only have 100 bytes of data read from the browser over here. That only 100 bytes are there, valid bytes are there that we have read. So it sets the limit to 100. So basically, we can do the same thing with a byte array of our own, but byte buffer provides us uh, a kind of utility to do that without writing that index code. Uh, we could without writing those index code or managing the indices or ourselves. So this is just flips or what is called moves the read index or write index to 0 from the start and sets the valid number of data read till now to the number of data that is read from the server that is stored in the limit. We are using that. We have to start from offset, that is the index 0, and read till that many bytes, and this string will have those as a string, and we'll print it to the client command line to see what is coming in our way. Go here, I'm now will say http server.java. We have our server running on this IP and port. Go back here, 5432. I will say, let's see what's happening. So we are getting multiple requests because this is doing multiple attempts. For example, it had made call thrice, so we have 3 printed requests or more. I think we are getting as many requests are coming from the server printed over here. So you can see we are getting get. This is the method type. This is path. This is protocol version that we are implementing. This is the host name and port that we are using, and browser type, Windows type, the Chrome user agent, what it is there, what it accepts, what is unaccept, and so on. So what we need now is we want the path here so that we can return data to what is called to the browser. So we can start, and we can go over here and say first we need to extract those. First we need to extract the path, and I will say after flipping I will say while request data buffer dot get is not equal to 32, that is the byte for breaking that we have to break here. And one more thing I need right now is that we need a crlf. It uses crlf byte to separate the header, separate the data from the header. So we need that here. For example, I can say final string, make it a static, is equal to rn. The use will come out, we will find this later on, that's why we need it. Why do we need it? So request data buffer dot get is not equal to 32. Then until then we can keep moving, so that this will what is going to happen, that this is going to skip the method part. But if you want the method, then we can have it here. You can say final int method start index is equal to 0, or I can just say request data buffer dot position, the current position at where our next read will happen. And once this is done, I can say final int method and index is equal to request data buffer dot position, the position at which we are finding a space. You can see in the terminal here that we have a space after method, so we are finding this, that once you have a space, we stop moving forward. After that, we can say final string method name is equal to new string data buffer dot array method start index, and this is where the string will get its start reading the data from the byte array, and method and index is going to be -1, because when we call the get, it reads the data and moves the pointer forward or index forward. So when it reads the space or byte that represents the space character or break character or CRLF character, it also moves the pointer forward. So we have to subtract -1 from here. Let me print the method name. We'll say print percentile n for line break, and that's method name. And next we need is the path. So I will do the same trick here. I will say here I will make a comment that read method type, and here I will say read path. That is it. While the buffer isn't equal to empty, keep moving forward. Final int path start index is equal to request data buffer dot position. Path end index is equal to request data buffer dot position, or I can say -1 over here, that it brings it back to space. Then I will say -1 2 to bring it back to the last character that was read. That was the valid part that was read. For example, if I go back here, when it starts reading byte from the array, it is going to be read G, then E, then T. When it reads space, it breaks, but the position is moved forward to this character, that is starting of the path character. So we need to subtract -2 to bring the position back to T to get the last index of that valid value. So I'm subtracting -1. For example, if I go here, it will compare it, read the character front slash, and then it will read the character space. When it reads the character space and breaks the while loop, by the time it has moved its pointer to H, position to H, so we have to subtract by these two characters to reach back here. But we are reading from the byte array, so I'm just do -1 subtraction. I will say find string URI path is equal to string, and I will say I'll do the same request buffer array path start index path index, path end index, as we have already subtracted one right here, so we do not need to subtract 1 over while we are using that index value. And I will say URI path is URI path. So we're just extracting method name and read path. That's it. And to give more to see what exactly we're storing in the array, I will first reduce the size here to, I think, make it 5 1024 512 bytes. Otherwise array printed is gets very big. So I will say, after reading what it is there, I will say println and arrays dot to string request buffer dot array. I think we need to find where the arrays is stored. So let us see what is the package name of arrays. It is java.util.arrays, so we need to import that. This will just print the entire byte array as we have get from the browser. This will print the method name, this will print the path. Let us see what is happening. Okay, no compilation issue. Refresh it, nothing happens. Hit it again. So this is the byte array that we are receiving from browser, and this is the part where we are using the 32 to match space. That's it. We extracted the method name, that is get. So what happening is that after reading this, we are, I think, clearing the request data buffer dot clear to reread to use it over and over again. So I think we are getting some issue with that. I think this value, that the value keeps changing. You can see we are getting get, then we are getting URI path, then it is getting get. So I think that is causing some issue. So we are clearing byte buffer now before we are reading again, using it again. So over here, or I can just make it use it over here, that just before reading it, clear it. Let us hit again. Okay, now the output is consistent, but we are getting issue because I think we do not have correct overall index of we are not getting the correct end index of this position. So this is a path index. The path index cannot be, we need to pass length over here. So I will say path index minus path start index. I'll do the same here. Method end index minus method start index to give the current length that we need to read from the buffer. Start again, go here, hit it. Now you see that we are just getting the correct value, that we are getting a empty path. And let me show you a different URI path. Now we will send an index.html request, for example index.html, and we should see this index.html from printed in the command line. You can see we are getting the index.html. If I say something like uh, first index.html, then we should get the entire path first index.html. We're getting the first index.html. So we are able to extract the path successfully. Now what we have to do next is now we need to write back to our server with the requested uh, resource. For example, I will go back and say if URI path, I'll just use here int length is equal to path end index minus path start index. I will say URI length, and I will say if URI length is equal to 1, that is we are just calling the home. For example, it is just a front slash, then we can say read data from home.html. This is learning Java. I will say create new file home.html. Okay, we'll write the HTML now and head title and title title is going to be home, and we'll have some body to show it that some data is there. This is home. We have a home HTML, and we also need something like index.html, and I will say let us change the title to index. This is index. We are not now traversing the directory, but we are just only returning a we will be returning a file or path from here. Or in case we can delete this, and I will read something from maybe archive classes dir1 dir2 dir3 first one projects. Mhm. Let us open this index. This is our index.html. This is a big file a bit, so it's going to be helpful in looking at that our code is working, and it is working successfully. So go back here, we have created our test file, so it is saying that read data from our home HTML. Okay, and else read data from the URI path location. Now it is our turn to write request back to the browser. So I will say string writer I will call it response writer new string writer. Go back here and look for where is string writer resides. Java io.stringwriter. We have already imported everything from there, so it should work. Go here, string writer, we have response writer, string writer, and it comes with write string. So we'll start with writing our request. We'll say response writer dot write. What is going to be, what do we send back to the server when our code is correct? Let me check. Hmm, what is the correct? Just want a example where you can see what is CRLF is. This is the character or string that separates headers and other data from each other. Our is going to be response of success, so it is going to be 200. Okay, it is going to say 200. Okay, dot, and we need more. I need a successful response example to write the implementation. Version resource. There's a general syntax was written somewhere. General syntax 19. Okay. Maybe there should be some other specification implementation where the example is text 2616. This space separates the values and this separates the pair of values from each other. Protocol parameters. Okay, I will come back to this it later. Let us write till now. Uh, it is going to be, this is going to be header, so it is going to be in pair. So I will say response write dot crlf, and I will say files dot read all bytes from home.html. Final content is equal to this. Let us create a variable outside. Content is equal to nothing. Content equal to this, and in the second case it is going to be read all bytes from URI path, and URI path dot, I will say path dot of URI path dot substring, 1 because URI path starts with front slash, so we have to remove that front slash. So we are removing that part. URI path substring. This will give us the content that is posted to the browser, and I will say content length is equal to content length, and I will say response writer dot write content. I think it's something like content length. We have to provide a header where content length is given. uh, Let me check my website. If I do a request, what we get? Response headers are there. Content length, this part, content dash length column. Content length, content dash length column, and there is going to be space there. So it is space and close it, and write again a response writer dot. Do we have write int for string writer? Write, okay, write a single character. No, this becomes a character. We need to write int. Or I can just say write crlf and content length, just concatenate it and return read the content of the file. And content length, we have added this header content length, and go back to my website and see what is the status for success 200. Okay. Hmm. You can also write content type. Content type, and go back and say content type text HTML, text front slash HTML, and char set is equal to char set equal to UTF-8. I'm not writing date. None of these contents are necessary for our generation for serving our request from the server. And request headers are this: request URL, request method, status code, simple response, was successful, just serving something like that. We have to provide user with the browser with a success that's our success code that our request is successful, but I'm not able to find any sample request that in what format or sequence we are going to serve. Request line method, request header response is there, simple response, full response, simple response is entity body, status line. They have broken into small pieces, but I want to see something like proper string format of response. So we have status dash code. Okay, come back here. I will say status dash code is equal to 200, a is equal to 200. Okay, as per here. And we have written crlf at the end to separate the content, to provide difference between two different header, two header pair or value. Full response status line. First line of a full response message is the status line, consisting of the protocol version followed by a numeric status code and its associated textual phrase, with each element separated by a space character. No CRLF is allowed except in the final CRLF sequence. So it is going to be status line HTTP 1.1 space status code 200 and OK, reason phrase, that is OK. Okay, it is going to be status line, and it is going to be let me get the we had printed somewhere a string, entire string, to see what is coming from there. This is the protocol version, HTTP front slash 1.1. This is a status code, this is the status phrase, and where is our this is where we are getting our information from. The OK has K as capital, then go back, make it capital. This is the status line. Just move back here with the rest of the headers. I will say write headers, and this is the content length. Content type is there, status line is there, content length is there, and what else we need? Save it. Now after response we are going to have to write data. So what are we going to do with data? Entity body, go back to 7.2. The entity body sent with HTTP request response is a format, some nonsense from the browser, and encoding defined by entity header fields. I'm sure I don't want this, not needed. Length, we provide the content length in the header. Options, get, post. Response writer dot write content length, response writer dot write. If I go back, to where I have come from. We came to here. I can say here are the entity headers. Content encoding. You can say UTF. We have already provided the UTF-8. We have given the content length, and we are not providing anything else. And this needs to be separated with CRLF. We see here that after the headers we need to separate the body with the CRLF. So we are going to write that response writer dot write CRLF, and we will have to import this files class to make it work. I'll say files nio.files to file.files imported java.nio.files and read all bytes, and we have read string from path, read all content from a file into a string. But in that case we'll have to uh, get the bytes and then get the length. So what we can do, I will say read a string, simple string, string content, and I will have to say path of this URL length is equal to 1. Then we have to read from home, otherwise just read the file here, and we need content string, so content length. So I'll just say it is going to be content.get bytes, get bytes. Let us open the string class and see what get bytes does. Either it is get bytes or just bytes. Get bytes encodes the string into a sequence of bytes using the default char set, result into a new byte array. So we are creating a new byte array. I think we do not need it. I can just say undo all this. I don't want to create a new array again. Read all bytes. We have the content length. We have the response writer.write.crlf. I will say final string headers is equal to response writer.toString. I think. Let me check. Let me go to the class and check that how I can get the entire string back. We have toString to get the string, so I will get that entire header that we are going to write. response header dot to string, we get the headers, and I will say uh, request we split. We have request channel dot write. We write the byte buffer, yeah, from the socket channel. Going back to this class, and we are going to call instance methods write byte buffer dot src. This is going to write to the server. No, not to the server, but back to the browser. Write byte buffer dot wrap. We are going to have headers dot get bytes. We've got the byte here. Headers written to the server, to the browser, not server. Keep saying browser, server, browser. Now we need to write a request channel dot write byte dot wrap, and what next? Write the content. Write the content. We have written both the header and the content to the browser. Okay. Write writing content to the browser. This is the header written, this is the content written. So we have provided a request to the browser. Now we need to check that it is working or not. We need to add this CRLF to what it's called, separate entity headers from entity body, and I will say request channel shutdown something. It has some function, shutdown input. I don't know what it is necessary or not, but maybe this will increase resource efficiency usage, because once we have read from request data buffer, we do not need uh, this input channel. I will say request channel dot output, shutdown output. I think the server is complete now. Let us all we have to do is check and see if it is working or not. Line number 60, we are missing a parenthesis. Cannot find symbol request. Okay, request, it is going to be request. What line it is? 29. It is request channel. And what else we have? Can't find symbol path. Okay, we need to import path. nio.file.path. But nio file.path will just say cannot find symbol response writer. Okay, 71. We have started the server, but I'm going to stop it, clean the command line and run it again. uh, Close this, open again, and let me make a request like this. uh, we haven't received any response header from the server. Let us see what the error is. I'm going to remove I have to remove this log. So we are not getting any success till now. Let us see how we are going to do it. How we are going to get successful with creating a web server. Preview has nothing, headers has nothing. Okay, let's come back. Method name get dot URI path. Method name get dot. This is the method name. This is the URI path. So what is the issue? What is happening? We are also not getting any exceptions. So what could be the issue? Headers is we are having some issue in writing headers and that, but I think logic overall is good. It should be working, but it is not working. I should be at least we should be able to send these headers to the browser, but it is not happening. So let us see why. Buffer underflow exception. Some exception is happening. At line number 172, might is 39. Okay, let us see. Request data buffer dot get is not equal to 32. No, this is not an issue because we are we are clearing it. Then this should be able to read the data again in the same buffer. Request data buffer dot flip. Prepare it for reading. Okay. Uh, Line number 74. And just hit the request. Okay. Method name get URI path is correct. Status line. Okay. We have our content type properly set. We have content length 92. We have headers given. Should be working, what it is not working. Let us try another way. We can just after writing the CRLF, we can just write the entire response. Writer write new string. I write the byte buffer as a string, and it is written. Mm, and we won't need to do this. I'm just trying right now to make it work. It is the headers. Uh, then we need the bytes. Let's run it again. So see, we're getting our response or not. Okay, we are successfully reading path data from the file, and this is also end headers. This is also end headers. Where is the start header? Okay, status line HTTP 1.1200. Okay, what possibly is the issue? Let's go back to spec to find what is happening. Simple response, just the entity body. Okay, status line. The first line of full response message is the status line consisting of the protocol version followed by numeric status code and its associated textual phrase space. No CRLF allowed. Okay. Okay, let me. I think a status line is not an header, so it is not needed. I think this is how it should be. HTTP is saying HTTP slash. Since a status line always begins with the protocol version and status code, so it should be something like HTTP 1.1200 space. Okay, reason phrase. So 1.1200. Okay, and we are separating all the headers with CRLF. Let us go back and try making request again. Okay, it is working now. So this is home. So my issue was that I had uh, implemented it incorrectly. I was considering this as a header type that we have to write the key status line colon, then the version number, status code, and like that. So with that, it is there, and we have our first response, and I can say index.html. Sorry. Okay, so we are going to handle this 404 also in our code. So I will say to start here final, or I can say path resource RSURCE path is equal to path dot of, not here, uh, I'll just say URL length is equal to 1 path dot of uh, home.html path dot of URI path substring 1. This is the resource path, and we have to check that this file exists or not. I'll say file uh, it is going to be java io.file file java io.file. Go to the constructor and say file. Though Microsoft Edge is not a good browser. File content, I'll say file uh, resource file is equal to new file resource path dot to URI. Can execute, can we have to check that exists or not. So I will say if not source file dot exists, then we'll just return the 404 response code. I will say uh, response channel, what is the variable name, request channel. Channel dot write http 1.1 404 not found get bytes byte of dot allocate and request channel dot write byte buffer dot allocate http 1.1. So what is going to be the status name for phrase for 404 is not found. N and F are capital, rest are small. So that is what exactly we wrote. And there are going to be no CRLF, nothing. Request channel dot shutdown shutdown output, and we return from here that if it does not exist we return 404 and we go back Otherwise, we process the and return the response. In that will this will also handle this favicon i.ico request. Method allocating class byte buffer cannot be applied to given types. Required int. Okay, this is going to be wrap. Content might not have an initialized content dot length. Okay, true, and I will say files dot read all bytes from the path resource. Do we have any exists function in the paths class? Let me check. If it is there, then we won't have to create a file object. Exists. There is nothing. Go back to path. Get parent get root of resolve starts with to file. We have a to file object representing this path. Then I can go back and say instead of file object, just set file. Okay, so this is the 404. I'll say handle 404. Here request channel shutdown output. That's it. Let us run our code. Let's run our server and see if it handles this request or not. Go back and I will say continue. I had written return, so shut down. The server closed after a 404. So I will go back and hit 404. We should be getting 404 response from the server, but we are not. An established connection will be voted by the software in a host machine. Why? 61. Go back to page line 61. Dot right buffer 404 not found. Maybe string writer. Over here I can say not found. Bytes. Continue. Let us check again if it is working or not. Response writer write CRLF. Response writer to string get bytes. I should be getting the 404 response from the server. Response writer write we have 404 not found. Then how should this specification handle this? We are making some mistakes somewhere. Let us see. It is going to have I have exception. $64. No idea why this is happening. What is the issue? Hmm. Okay, this is with the 404. Are we able to serve other valid requests? That is also not happening. I think error is happening somewhere else, and we are getting error later on. That's why we are not able to figure out to URI if it exists. Let's check that again. When we introduce the file to check for the path, we are getting this IO exception error reported by the software in the host machine. There's nothing wrong with this. We are able to successfully read a file from given path. Something else is happening. 86. There shouldn't be any issue again. Let us see again. Okay, I think the shutdown input was causing some issue. Go back to 404. I think we should be able to in this case favicon IO we should be able to get 404 that we are getting. 404 not found. Content length as 0, and it request the home. So our code is working now. I think this shutdown input was causing some issue. I'm not sure why, but this is what was causing the issue. Let's remove it. And our code should be able to serve any file. So this Java file should also be able to come to our front end, can't reach the page. Okay, so you can see that we have our Java source code that we are using to run the server is here. We can read also that path. For example, let me go back to the terminal and say close it. I will make some like catalog, and I will say copy item index.html to destination cataloged as catalog.html. Done. And we can come back here and say catalog.html. It should work. Okay, our server is not running. This is not a good browser. We are not getting any error. We are able to fetch data from catalog HTML, sending the status as 200. Okay, content type as text.html. All is good. Still not working. Let's see why. index.html is there. Hmm. Okay, we have catalog.html working. I have no idea why that was not working earlier. With some browser issue, and we can add more things. For example, let me close it, and I will say uh, no. I will just go to my editor and say edit catalog.index.html. I will say html. And what I'm doing is that catalog index, that in case where we're just uh, you have seen many servers where you just provide the directory, it reads the index.html from that folder. So we will be doing just that. I will say h1. This is catalog index file. That is it. And I will go back to the Java file and say, in this case, I will say I will have to go back here. Go by over here and we'll have to modify the resource path later in the while we are reading the content. So I will say let us remove the final word from here, and if I say if resource file is directory resource file, let me go to the file and say how to check for directory is directory then resource path is going to be, let me go to the path class and see we can just append something. Subpath to absolute path, resolve resolve path first. It is a static method of a string of URI. Instance methods we have let's create a new path. So I'll say path dot of URI path dot substring 1 and at index.html. In case when we have a directory, then we will just read index file from that directory. Resource path. So let's go here and create a new browser. Open a new tab. Remove the catalog index.html catalog.html from the path. Start the browser. This is catalogs index.file. So you can see that we can directly read, we have made changes that we can directly read index file from catalog folder. So our server is able to serve HTML file from the current folder, HTML file from a path. It can basically serve a file that is text based from any location. We can modify to serve for image based file from any location. We can directly provide the path, for example catalog.html, it should work, and we can directly say things like this. Well, this is the catalog, this is home. When the length is 1, we can just say index.html. This is the index.html file from index.html, from the directory where our server is running. So we can serve text file from any location relative to our server that can be defined in the URL path, and we can modify it to return an image also. For example, if it has PNG, that we just read the bytes and return it without it with obviously the content type is changed, but this is how it works. So hope you learned something from this, and see you in the next class, and thank you for watching.